Cool. Yeah, so the things that I wanted to go through today is I was working on a first pass of the simulation class, and that involves a bit of restructuring of, well, the data, the survey, and tracking the problem. So I wanted to like chat through that and make sure that what I'm thinking hopefully makes sense to other people and get feedback before we sort of start going like too far down. Just make sure that like this is looking right, and then we can start trying to inject it elsewhere. But maybe before we get into that, are there other things too that you guys want on the list on the docket to chat about today?
Well, it's again, not for me, the prioritization over the weekend. So we would be good to start putting into the while we do the PF factorization.
Yeah.
Put it in if we wanted to.
Oh, so you got the multiprocessing working in the class?
Yeah, well, it's not in the class, I know we can go over it later.
Okay, cool. I really appreciate chatting through.
Yeah. And it kind of it requires to move the functions that we're going to parallelize outside of the main class. It needs to be kind of called outside.
Ooh, okay.
So it's like an additional file or class that the main class can just call in.
Okay.
Yeah.
Okay, yeah, let's chat through that.
Yeah. Because since Thibault opened a PR for potential fields, right? Put it down at the same time.
Yeah, well, there's a couple things with those PRs that would be worth maybe you, me, and Thibault sitting down later and chatting, because I think there's you have the mapping one. There's a couple pull requests right now that touch some of the same code, okay. So we just need to like figure out order of operations is all. It shouldn't be too big of a deal, but we can sit down and do that. Cool. And then D1 posted a question on Slack. You were asking about reading in UBC meshes?
Yeah, so here's the background. Just a brief talk. So now I have my code, which are mostly written in MATLAB and Julia. Some legacy codes that can basically handle the read and write mesh and do some manipulation. For example, at the block, at the sphere, at the cylinder, or create a model with like a some sort of one structure, all kind of stuff. So some are simple, some probably already implemented in SimPEG. Something maybe very interesting, maybe useful. So I'm trying to converting all the codes to Python now. And then before doing that, I realized probably something has been done within a SimPEG package. So I just want to take a look, and looks like there are actually something like read and write, but there's no example or like no, not quite sure whether this is just something you did many years ago, or like stopped making update, or like people are still actively working on this, or just utilities.
Yeah, so those are actively being maintained. I know that Thibault has done a whole bunch of testing between SimPEG and GIF tools, making sure that like we can write out meshes, read in meshes, and all of that through all of that pipeline. So I think he's got a few examples kicking around, but you're right, they're not online yet. So is there one specifically you're interested in, or?
For now, simply read a UBC mesh, read the UBC model, and maybe do some modification to, for example, add or remove some structure to the model, then write back to disk, that kind of thing.
Okay. Yeah, that we have.
Because most of the existing examples in documentation are like creating a mesh from scratch. Yeah.
Look at the PF, look at the PF examples, the Laguna, that's like straight up reading in, reading out meshes and models. Gravity, look at the gravity example, Laguna.
Here you go, Dom. Can you try it again?
Laguna Del Mal, in the examples, I'll send you a link right now. So I just posted that on Slack on general. So this one, I believe, yeah, that we downloaded a zip file where we have the UBC meshes. That's all UBC form?
Okay.
Yeah. Yeah, and then, I mean, once it's once it's read in, it's basically just indexing into a vector and changing the indices you want to build up a model.
Yeah. Okay, I will take a look. Thank you.
Hey, no. Could you get fine?
Sorry. Are we at the pool?
Sorry?
Are we at the swimming pool?
Oh, yeah. Yes.
Oh, by the way, one last question. Sorry.
Yeah.
So for all the utilities that manipulate model or mesh, they're actually in the discretized, right? Or
So utilities, the utilities for reading and writing the mesh are all discretized.
not in the SimPEG.
Oh, Timo, is that true?
Yes.
Okay. Yes.
Okay. Yeah, just want to confirm.
Yeah.
All right. Okay, thanks.
And then if you have like model builder utilities, that's something like we need to clean up a bit in SimPEG. We do have some of that stuff kicking around, but it hasn't been looked at in ages. So that's something that if you built some examples, we can chat about that when you're sort of ready to talk about bringing them in.
Okay, good. Thanks.
Okay. All right, then let's maybe switch gears and chat about the simulation class. So I was telling these guys that this changes a lot of, it obviously changes a lot of code, but the biggest things we're touching here are, we're scrapping the problem, so that goes. This will change the survey class, this will also change the data class. And we'll start relying much more heavily on the data class, which currently we hardly use. So I started a pull request, and you guys are welcome to comment on it. It is not tested, it's like very much a first pass, but I wanted to get feedback at this point to make sure that what we're doing and like how I'm thinking about this hopefully makes sense. So I've started here. The pull request is in the email, but I'll also just put it on Slack. So I think what I'll do is I've got an example here that uses, it's the linear problem. And I've got it hooked up now from forward and we're inverting sort of in this new framework, I guess, because we sort of are restructuring the framework. And the way I'm sort of going about this right now, I'm actually just writing like a new survey class so that I can still import both and check that functionality is working. So there'll be, I'm trying to do it in a way that like later on we can just take new survey and scrap that and call it survey. That'd be fine. But for now,
like basically is the idea to make a new class that sort of has the components of survey and problem together.
Yeah, sort of. So the survey will still exist on its own, but the idea of a simulation being that like it is the complete path. So the simulation now actually has a survey property on it. Actually, let's maybe look at this first, because this will just give a bit of an overview, and then we can see what it looks like in action.
This is mostly for visual field?
No, this will be for everything.
Yeah,
so this will touch everything. Because what we were finding, Dequan, is right now we sort of have this problem, and then you pair it to a survey. And this is a little, it's a bit non-intuitive. And also it's starting to cause problems when you're wanting to parallelize, because it's not something like that paired object, we can't properly serialize it and send it out to workers. And then it leads to some non-intuitive things, like when you're trying to plug in somebody else's forward simulation. So hopefully this will remedy a few of those things. Okay, so the survey has been lightened a lot. So before it used to have like dpred, we used to be able to make synthetic data and all of that on the survey. That's gone. The survey right now is just, where are my sources, where are my receivers, and how many data do I have? That's it. That is the survey. And so with that, we can strap on some utilities for like rapidly creating surveys for DC, or if you want to perhaps index sources and receivers by frequency or by type or whatever, like all those utilities can be attached there. The survey also used to have the data attached to it. So it used to have the observed data and the uncertainties. Those are now in the data class. And so the data class is like a self-contained thing. Which we
I think that makes sense.
Sorry, Deepan?
I think that's a good idea.
So now the simulation encompasses what the problem used to do, as well as some of these pieces that were in the survey. So we now have, like, it's instantiated with a mesh, a survey, a solver, and then it has the methods, fields, defred, JBack, all of those. It also now has calculate the residual. This is a subtle slight change because before it used to be on the survey, which also knew about the data. Whereas here, the survey has no knowledge of the data. And so you have to pass your observed data to figure out the residual, which I think is fine, but that's just a subtlety. And then it also has the method make synthetic data. And unlike before, when this returned a vector and it modified the class, this now does not modify the class at all, and it just returns a data object. And so a data object now has the observed data, it has your noise model, and it knows how to like sort of slice through your data in reasonable ways. So dobs is always just a vector. We're not going to touch that. It is like, this is something we can chat about, but in some ways I want to make it immutable so that like once your observed data is attached, like it should never change. But that's something to
just one thing that I guess I see coming for my problem, maybe time domanium problems, is that you may choose to invert a subset of the total observed data. So if I make this many field observations and say I'm doing what Soggy's doing and I just want to invert the early time channels, is that sort of been considered, or is that sort of?
So in that case, what we can do is that's then just a mapping applied to your observed data, basically. So we would just say, like, grab these early time channels, and that's all we work with. But your observed data, like, we're not going to go in and delete anything. We're just going to say, this is the subset you should grab. So that's all through mappings.
Okay.
But do you have a switch on and off, like in the inversion? Let's say we got 1,000 data.
Yeah.
And I want to invert for 200, like that.
Yeah.
And then, like, do you have any switch in here that you can turn on and off?
Well, so you would do that through a directive. So you have your mapping that says, I want like these 200 data. And then if halfway through conversion or once you've converged, you want to then invert all the data, you just have a directive.
Data has a mapping as well.
No, data does not have a mapping. That would be in the data misfit. Yeah.
Doesn't have a mapping. How do I do a mapping?
No, data misfit has a mapping. So it's just a projection. Like it's basically all it would do is say like grab these early 20 time channels for each data set.
If you wanted to, there's no reason you couldn't make a separate data object, which was just a subset of the original.
Yeah, absolutely. Yeah. Yeah, so both of those are options. Okay, so let's look at an example. And I'm going to flip back and forth between the notebook and some code and just show you guys a few of these pieces. So let's show this over. Okay, so this here is the just the linear example where we have those exponentially decaying sinusoids, and it's inheriting a linear simulation. So I want to show you what that is. Okay. So the base simulation has these things. Fields to spread, JVAC, da, da, da. And then the linear simulation in addition has G. That's it. And then everything you already have. So similar to what we had before. And then in addition here, so the only thing that I have to do in this simulation is just tell it how to construct G, and then we have all the rest of the pieces. So we do that. Oops, my RV. There we go. So then we just create a mesh. And then here, where all the pieces are being attached as keyboard arguments, which is kind of interesting when you start thinking about plugging in simulations like Dieter's, where maybe we don't actually need a mesh. And so, like, there's no reason that I'm going to force you to add one. Yeah, so that's interesting. And then here, what's nice too, then the simulation will serialize. So that's important for parallelizing, because then we can actually, like, that means that this thing can pickle and we can send it to
what does it serialize in the simulation class? Because there's all the properties.
Yeah. Yeah, so we can get fairly fine-grained on this and tell it exactly what to serialize, but right now, what's nice actually about this is that all of these properties are actually things that you do need to recreate the class. And so
what happens for the solver, for instance? Like, let's say, okay, you serialized it, and then if you want to generate your simulation again,
yeah.
how do you do that?
So right now, the solver, I need to plug it in as a property. So that's a to-do, because I don't know how to make it, actually, we have to write a custom property so that it can be either a PyMat solver or a SimPEG solver, which is not a hard thing to do, I just, but once that serializes, then you, like, any sort of properties or options that are on that class were also written out. So here you can see, like, the mesh, since the mesh is also has properties injected, it serializes all of the pieces that we need to recreate that mesh. So we know what X naught is, we know what H is, and all those.
So let's say you got that.
Yeah.
You got that dictionary as all the information.
Yeah.
And then now I want to generate a simulation option. How do you do it?
Oh, so in this case, so if I have, then we'll see if this works. So my options. Should just be that. I don't actually know if that's gonna work,
That's right.
but
But that's what you're aiming for.
yeah, yeah.
Cool. Yeah.
So
Great.
yeah, so we'll get that hooked up. It's not there yet, but we'll get it hooked up. Okay, so then we create a model, and then we can simulate predicted data. So it's the simulation that is getting the predicted data. And in this case, predicted data is just a vector, which I think makes sense. Then here, if we actually want to go and create synthetic data, what it's going to do is actually give us back a data object. So the date, I'll show you how this just happened. Okay, so
switching all the naming convention to small.
Yeah, so
underscore, or what was the capital?
Oh, camel case. So camel case should only be on classes, and then underscores should be like methods and properties. So what I'll do so that this isn't too painful is I'll do like what we did with mappings and make sure that it is like, if you call it with the old name, it's going to throw a warning at you saying this is going to be depreciated, and then it'll still do it. So here, when we make synthetic data, it takes a model, we've got a standard deviation, and if you've already pre-computed fields, like if you're doing a big problem, then you can pass those. We got our clean data, we add some noise, and then here we return a data object, which has the observed data, it takes a survey, and it takes the standard deviation, as well as potentially a noise floor. So observed data, standard deviation, noise floor, survey. And then uncertainty. And so what I've tried to do here is enable two use cases. So if you want to just set like a standard deviation of 5% and a floor of 1 times 10 to the negative 12, you can do that. And it'll calculate the uncertainty. Or if you want to actually go and calculate your uncertainties on the outside and provide a different uncertainty for every datum, you can just specify an uncertainty. And then same thing, like if you wanted to do like a standard deviation by frequency or something like that, you can provide a vector of standard. So it can be a scalar or length. That is the length of the data. And then what's kind of nice about this, so originally what we had in the data class is the data would actually be, like the purpose of the data class was just so that you could index through your data easily. So the data was actually like rearranged into a dictionary. So here, I don't do that. We leave the deobs as just, it's a vector. But what we do is then go and find the indices that allow you to sort through it by sources and receivers. So what's nice about that is then we can also go in and like later extend that if you want to sort by line number or those kinds of things. We can start to build utilities around just finding the indices of what are associated with that given line or whatever. Yeah. So here, now that we have the data, we actually have, so we can look at our standard deviation. And there's no noise floor, which is fine. And then the uncertainties are calculated based on the standard deviation. And then you can also index this by source and receiver, just like we do the fields, or just like the old data class used to.
That's the UID that's coming up there.
Yeah.
Can you show us in the data class what the UID is on?
So, okay, so what that is doing is it's actually looking at this data dictionary. So this isn't just the UID of the source, it's actually the source object. And then it's going to go, and we have sorted. Okay, so when we create the data dictionary, all we're doing is like providing the source and the receiver as keys into a dictionary. So first, at the top level here, we access by source, and then beneath that, because every source is a receiver list, we access by receiver. And then one thing I would like to do is extend that one step for time domain examples, so that now you can also index by time. But we can do that later. Does that answer your question? So it's the same like as what we pass the fields object.
This data class is still paired by survey?
No. Oh, so sorry. It does take a survey. So you instantiate it with the survey because we need to know what your survey geometry is. So like when you're setting up an inversion, your data class needs to know about your survey and your simulation needs to know about your survey.
Yeah, so where does that connection happen? Because when they're making synthetic data, you're not really passing that survey class. But it does know from the simulation, is that?
Sorry, just a sec. So simulation. So when we make synthetic data, it passes the survey. So that's already been hooked up. But if you did it on the outside and you're passing field data, then you need to instantiate both of these things with the survey. Okay. So then the next thing that's changed is that the data misfit is then instantiated with a data class and a simulation. So before it took a survey, no images. And I'll show you just what that looks like. So here, takes the data and a simulation. And so when we go and let's look at the L2. This should even be on the base. But so here, the simulation has a residual method where you have to pass it the observed data. But now that we've hooked up both of those things in the data misfit, we can just call a residual data model. And so here, when we're computing derivatives, we just ask for the residual. So this then propagated like a couple changes in the improv and all that sort of stuff. But those are all completely internal, so that's okay. And then none of this changed. So this is all exactly the same. And then we can run. Does that sort of make sense? Is it first pass?
Yep, that's pretty good.
Okay. Yeah, because one of the things I was initially thinking, like the survey and the source list are almost the same thing. So initially I was thinking about just passing the source list around, but I figured that having a survey later on will allow us to be a little more flexible. If we want to have utilities for like setting up that survey, because if you think about like a ground-based survey, sort of passing your receiver list to every source or every frequency is non-intuitive. So we can perhaps have some stuff around that to make it a little more intuitive.
If you have methods that act on these objects, then if you have multiple source types, you may have to write methods for each source type, whereas you might be able to, if it sort of acts on the source list itself, you just have one method for a class survey, which is also good.
Yeah. I think.
Are you referring to the situation effectively we had in the ISR where you got like one fixed loop, so you got one transmitter, but then they actually put through two different waveforms in that?
So each of those would be a different source, even though they're co-located. Each of them would be a different source. Yeah, and so sort of like having something that, like we can have a utility that like generates an ISR survey. That sets that up.
Would it be, since we're already playing enough, so right now, the receivers could be duplicated in multiple sources. What if you have let's say you have two big loops, but you have a fixed number of receivers, all the receivers are duplicated.
Yeah.
Would it be possible to just index like unique,
They shouldn't be duplicated. Like they should still be accessing the same thing in.
Yeah, it's not duplicated. It's
There's pointers.
so you've got let's say got a five receiver here. You pass for this source and that source. It's not duplicated. It's a unique receiver. So
but when is it okay? Because when you access it through the survey, right, it's the top level is the transmitter, and then you get the receiver list.
yeah, right.
But
But
it's just a pointer.
Yeah, exactly. It's a
Yeah, but like, to your point, it would be nice to just grab a like get all receivers, and then
Rather
that.
than a cycle through transmitter. That could be, we can just make a function inside.
I think that if you like pass column and just RX to the class, I think it will do.
It should do, yeah.
Because if you, let's say if you want to get all the receiver, data from all of this receiver, and then pass the column for the sources, I think it'll output all of the data corresponds to that receiver. In theory, right. But let's say, well, we got some utility codes that we can drape over from topography, for instance.
Yeah.
So I actually put it in the survey before. Where does it fit now? Like, is it in the data class or a survey class?
Sorry, draping what over?
Well, let's say you got electrodes.
Yeah.
And you have an air cells. So sometimes a given Z point is not quite right for your, like a mesh.
Yeah.
So you need to drape over your actual topography in your mesh.
Yeah.
Where does it fit? Like, where do you need to put that in?
I think that still probably fits in the survey. The other thing, and this is,
And also, how about the I/O? Let's say you have some I/O, like the UVC I/O, for instance. And then, well, like now we're separate, completely separate, but it generates a survey class.
yeah,
Which is still fine.
Yeah. I think that's what we want. So like I think,
Like the read from UVC format, it would now need to create two things, right? It would need to create a survey object and a data object.
yeah,
The only difference,
I think we just need to output the data.
Right.
We just need to output the data object.
Yeah.
That's a survey.
So that's
Survey is attach it now. It's kind of easier.
We need a survey.
Yeah.
Yeah.
yeah. So I think like what I would suggest with that is we try and keep those utilities like as a self-contained function, so that you can just call it exactly like that. So that we just call like read in UVC DC data, and that creates a data class, simple data class.
Okay, so when we create a simulation, why can't we just, since we're already asking for both the services, can we just put in data?
It doesn't. The simulation doesn't take data. Simulation has no knowledge for the data. Doesn't care. It only takes a survey. Yeah.
But then a misfit could only take data. No.
No, because it needs to know how to compute.
Okay.
Yeah.
That's good.
Yeah, so like the thing that I was trying really hard to do there is like separate, this is the inversion data from this is the forward simulation computation piece. Because before that was all muddled together.
When you come to like natural sources like MT,
Yeah.
and how does that fit into the structure? I guess in fact even gravity and magnetics where you actually have a an Earth source.
Yeah.
Setting up. How does all that fit in then with this?
Well, you still have like a source field, so you still have some parameters that are defining the direction of the spin. And even in this case, for the linear survey, there isn't really a concept of a source, and that's okay. But then that does make, so then that means when you're working with the data class, all you can really do is like ask for your data vector and your uncertainties. You can't sort of index it because you don't need to. So that all is okay.
Okay.
But then you like ask for natural sources, for MT, like the data transformation will have to be happening. Like the impedances will get calculated inside the simulation.
By the receivers. So we still have receiver classes, and the receiver class will take fields and know how to compute data.
So,
Yeah. So that's in the simulation. Well, I guess it is sort of in the survey in a sense, because it is the receiver who's doing that last step of calculating your transfer functions.
This looks much cleaner.
I think so. So, yeah, what I'll try and do is get an example, maybe going with DC or EM. What I sort of like actually about going for the EM is there's enough structure that will make sure that this really works. And then, yeah, we can go further on that, because this needs to be tested and all that sort of stuff.
What is it like? Is there any missing pieces or the to-dos or yes?
Well, none of it's tested. And I think a lot of the to-dos are going to come to light once you start trying to inject it into just a bit of into EM, something that's a little bigger. Yeah, which is fine. So I put this notebook, I zipped it up and put it in the pull request. So if you want to check out this branch and just fiddle with it, you're welcome to.
Do you have a new schematic diagram? I know we had the initial one that's like make mesh, and then that would actually be pretty helpful.
Yeah, in a lot of ways, it's just sort of like get rid of the arrow between the problem and the survey, and just envelop it all in a forward simulation is the gist of what's going on. But you're right, a new diagram would be helpful. So. Okay. Anything else you guys want to go over with this? Let's maybe just take a quick look at pull requests. There are a bunch. Oops. So, it looks like there were a couple that were failing, and so if it's failing and you haven't sort of pinged and said, can you please help me figure out why this is failing, I'm not going to review the code. Because one of the things that I'm looking for is like test coverage, and we don't get that served back if the tests fail. So if you're having trouble getting it passed, like please ping, but otherwise I'll just sort of like let you know that I'm not going to look at it until it passes.
Any failures in my pull request weren't actually related to any of the code that I wrote?
Well, Travis is failing. So, and Travis is passing on master. So.
Okay, well, maybe I'll update my, bring it in newly, but.
Yeah, so just have a look and update it, and then if you're still running into problems, I'm happy to help.
Sure.
But yeah, just know that. Yeah. So I think these two, no, so it's the local problem and the improvements for potential fields. There's going to be some conflicts that happen when we merge both of those. It shouldn't be anything too serious. I think it's mostly just like white space fix in one and white space fix in another. So, but we should go through that.
Okay. So we need to pull one to the other.
It doesn't matter. We can pull one to master and then resolve merge conflicts. It shouldn't matter too much.
Yeah, probably local problem.
Yeah, so I think the only request I had here was some doc strings.
That's for it's on that.
Oh, sorry, I'm looking at the local problem.
Yeah, there's no, there's a new mapping in there, right? There's a sun map. That I don't think so.
But that's not a different pull request, right? The sum map is on the.
Sorry, the tile map.
Yeah, the tile map.
Yeah. I don't think it's that.
Oh, okay. Okay.
Yeah. That's why I didn't do it.
That's fair.
It's bigger.
Yeah. Deep one, this is, for context, this local problem, that's a lot of the mesh decomposition stuff. And so Don's added a couple examples of how that will work in SimPEG.
Okay. What's the pull request number?
637. Here.
Maybe Deacon, I'll write an example and I'll ping you so you can look at it.
Okay, yeah. It's right in the pull request or in the issues?
No, I'll just script it or notebook it, and then I'll send it to you so you can look at it and comment if you want.
Oh, that sounds good.
Okay, and then Thibaut, we had one request. Deepan's looking for some stuff for reading in UBC meshes and data. I was just wondering, because I know you've done a lot of that, if you could point into like an EM example. Could we point it into a potential field one? But if you have an EM one, that'd be awesome.
I have DC, or check over here.
Okay, or DC.
Yeah.
Just enough to get a feel for.
It doesn't really matter as long as it's the UBC mesh, UBC data file, just a quick example, that's fine.
Okay.
That's good.
Thank
Okay. I don't really have any more things. Anybody else have any other?
What techniques are you going to kind of concentrate on for going through your reformulation?
Oh, for the simulation stuff? Probably the EM. Yeah. Because it has enough layers that should work like most of the challenges. Yeah. Deacon, is there anything else from your end that you want to chat about?
I think I'm good.
Okay.
No.
Cool.
So is there like a list of kind of EM types of surveys that you actually have? And then we could kind of test each one just to see if, you know, if I had this kind of, let's suppose I got an airborne EM with a single transmitter receiver that's flying long versus, you know, something on the ground that's got multiple loops and, you know, various receivers. You know, and just have like a list of a whole host of, you know, typical kind of EM surveys and just, you know, kind of just kind of check them on, see, oh, we can handle that, or we can handle that.
We don't have the list, but we can make it.
I think that would be something like that would be interesting.
Yeah.
To have just kind of sort of recalibrate, just to make sure that okay, we haven't kind of forgotten something that's a, you know, particular survey and whoops, can't handle that. So.
Yeah, that would be good. Insert an issue and just get a list going. Because it'd be nice to have an example of generic surveys. Because right now we sort of, well, we don't. So people have no idea what you can actually do with it.
Yeah, I think there's kind of a list. If we go to look at the source code, like in the SimPEG, there's the DCEM, under the EM, there's FDEM, NSEM, something like that. Kind of like a list, I think.
Yeah, but getting a little more fine-grained into, like, if you want to simulate an airborne survey or those kinds of things.
I see.
Yeah.
So actually, there's another question because we have like FDEM or TDEM or NSEM in the package. But in terms of actual implementation, are we kind of hard-coded like the E formulation or H formulation into each of them, or there's a option or switch to go back and forth from?
Yeah, you can go back and forth. So
okay.
All 4 formulations are there for the frequency domain and the time domain.
Okay, basically we'll have a choice to do either H or E.
Yeah.
The MT code is hard-coded to formulation.
Yeah, MT code is currently hard-coded, and so that's something I'm gonna chat with Mutiny about, because what we want to try and do, like, the biggest thing that just needs to happen with the MT code is that actually the sources and the boundary conditions are potentially different for the frequency domain problem. And so as long as the frequency domain problem can handle those, then it doesn't actually really, it should be a very lightweight package. So, yeah.
Excellent. Right. Well, great start.
Thanks.
Oh, that actually looks really straightforward.
Yeah. I think it's a little more intuitive. Yeah.
Well, and Steve Jobs would be very pleased with that, right? Intuitive. Since he tried to make everything in.
Cool. All right. See you later, Declan.
Oh yeah. Thank you. Bye guys.
So, not sure where you are on the Laylor stuff, but send something along, you know, even in a really rough draft stage.
Okay, sounds good. Down next Monday.
All right.
All right, see you. Bye.